Alright, welcome back to day 16 of LeetCode grind. Solve or go home. 30-minute solve or go home. Alright, let's see what we got. Remove the nth node from the end of the list. Okay, given the head, remove the nth node from the end of the list and return its head. What does it mean by its head?
No, you want the list after you take out that node. So you want to return the head of the...
Oh, of the new list. Of the new list.
No, well, yeah, sure.
Okay. Well, not the new list per se, but like the mutated list.
Right.
Okay, sure. Okay. So if I'm doing this, it says you want the nth node removed. That means, okay. So literally, I mean, isn't it like, is it against the spirit of it if I just looped traverse it and then just store the indexes into a dictionary and then just pull out the position I need to delete and then just go to that one and just do dot next equals the other one?
Well, first of all, do you need a dictionary for that?
Kind of, because I want to store index and then the index stores a node, but I guess you don't really need that.
Right. You just need a count, right? Like you don't need a...
What do you mean by counts? Oh, like, count
many,
the indexes while you're moving through the array.
How many nodes you've reached so far, right?
Yes, but then okay, but if you do that, you don't know when you hit the end. When you hit the end.
All right. So you go through again.
Oh, so you just loop twice. Okay, I see. So loop once, get the index. Loop again, get to that index. Just set the not nexes properly, and you're done.
Right.
Is that like a viable solution?
It's fine.
Okay, all right.
That's the expected solution, I think.
What? Okay, if Google Alphaz says that's expected, I'm gonna trust him. While head. I want to store the in.
So typically for linked list questions, you want to usually have a pointer for the head.
Yeah, you want. Yeah.
And return that pointer dot next. So.
Wait, why do you want to return pointer dot next? Oh, you mean traverse the copy instead of the actual head.
No. First of all, you never want to lose track of the beginning.
Yeah, so that's why you have a copy, right?
Yeah. So having a copy pointer is nice. And the other thing is, let's say you do something where the head is deleted, right? Then you will be able to still have the correct thing to return because your pointer or your node is outside of that, right? So it's very useful to have some kind of thing that you make a node and then that node points to head next.
Make a node and you point it to head next.
Right.
Why?
So
why specifically head next instead of just head?
No. That node's next is head.
Oh, okay. Oh, so you're making just like literally an empty node, and you just point it to head.
Right. So basically, that node will always be there, and whatever you do to the list doesn't matter, right? It doesn't affect it. So you can always say return, rets.next or something, right?
Okay, so basically you want where's the definition? Oh, it's right here. So there's 0 and then head.
You don't have to specify anything.
Well, don't you have to set the dot next?
Oh yeah, sure. That's fine.
Okay, so then while head. So we start at 0 index, so maybe wait, that's fine. While head. and then I increment count when I flip it to the next one, so this should be done at the end, so I don't increase too much. Okay, so yeah, if I set it to next and then I increase, then it should be fine.
Okay.
Okay, let's print count to see how many, make sure it works. Okay, that was fine. Okay. Alright, so then now head equals and then I want to remove the nth one. So nth.
Why while?
Don't you have to traverse it again to get back?
You have to traverse, but you know exactly how many to do.
Oh, right, yes. In range, it should be count minus n, right? N from end. So end is count, nth is the position from it. So if n equals 2, wait, why is, if this is n equals 2, why is it this position?
N equals, so it's 2 from the end.
2 from the end. Okay, so it count. Oh, so it counts that. So it should be n. It should be minus 1. If it was this, the end here count is 1, and then n is 1. So n minus 1 is 0. 1 minus 0 is 1. Wait. N is 1 here, right? Yeah, 1 minus 1 minus 1 is 0.
What if,
yeah.
What if count equals n?
Yeah, that's what I'm saying. I'm doing this example right here. So n equals 1. 1 minus 1 is 0. And 1 minus 0 is 1. So that's wrong, because then the index 0, 1 does not exist. Wait, actually no, that's not it. It's just not index. It's just how many times we loop. That should be fine. Okay, so
No, then you'll have it for I in range -1, which is
no, it's 1. It's 1. What are you talking about?
Is that an example?
Yeah, this one. So count is 1. N is 1. And minus
right.
1 is, so 1 minus 1 minus 1
is -1.
Oh.
What is the range of -1?
Oh, it doesn't work. Wait, that is -1. 1 minus 1 is 0. And then 1 minus 0. Wait, what? Am I doing the math wrong?
Oh, so it's right, but like I think you, instead of dealing with -1s, you can do count minus n, but start from ret instead of head.
Oh, so just do this, and then instead of using head, we just use ret.
Right.
But then that would change the position of ret. We still need ret to be pointing at the top.
No, yeah, you do, but you still have the pointer to ret. Ret is what you return at the end.
Yeah, but then if I traverse ret, then I'm.
No, you traverse head.
Oh, you're saying head equals ret instead of ret that next.
Right.
Okay.
You never change ret.
Sure. Okay. Sure. And then head equals head dot next, and then you just head dot next. Wait, this traverses exactly to the element. We want it to be in the element right before it, don't we?
No, you are in the element right before because you started with ret.
Okay, well, wait. So if it's count minus n, count is 5 here.
Okay.
n is 2. 5 minus 2 is 3. So I start
Yep.
from ret. I have empty, then I have 1, and then I have 2,
Yep.
and then 3. That's wrong. We need to get to 4, don't we?
No. You're at 3.
Oh, we're at 3. Oh, because that's perfect position because we want to remove this. Okay. Wait, is that correct? Wait, if I'm looping from 0 to 3. Oh, this is from 0 to 3, that's why. So it does 4 elements.
No. From 0 to 3 it does 3 elements.
Then you got 0, 1, 2, and 3, right? That's 4.
What's count minus n?
Count minus n is 3.
Right. Range of 3 gives you 3 elements.
Yeah, it gives you 3 elements, but you still have the empty one. Because ret is empty.
Right, so you moved next 3 times.
Yes. So if you move next 3 times, and you start
So
with
where are you?
empty, that's 1, 2, 3.
So you're at 3.
Yeah. But then, so that passed 4 elements, including the 0 element that we don't care about.
No, we never deal with the 0.
Yeah, I'm just saying it passed. It went past 4. Okay, that's fine. All right, so yeah, that's the correct positioning. So I just do head dot next equals head dot next, and that should eliminate it.
Okay.
Except it has a 0. Oh, because I have to return ret that next.
Well, you're returning what? You shouldn't return red.
No, but it's returning 0 with it.
I know, because you're returning red, which you shouldn't be returning.
Yeah, so I'm returning ret that next is what I should be returning.
That's correct.
Oh, okay, my bad. Your stream delayed, so you didn't see what I said. You just corrected me on something I already corrected myself on. Okay, looks fine. Alright, cool. Alright. I guess I'll do a few more. Ken's playing already anyway. I'll just try
That was fast. Okay, should we go back to the easy mix, or you can go to medium mix?
There's no medium mix, is there?
There's a medium mix.
Oh, medium mix.
Probably more relevant, actually. But the easy mix.
Where's medium mix? What are you talking about?
Just go click on that, and then click on the second. So there's a tab. Oh, scroll up. You see 1, 2, 3. Oh, no, go back. No.
Oh, I see. Oh no, medium might take like a long ass time.
It's the same thing, but slightly expanded. It's the same principles.
All right, what's good?
You've done like none of these, so pick your own poison, I guess.
I don't like to pick poisons. I guess I'll do a tree because trees are easier typically.
Oh, no math. You're not a fan of math.
I don't know any math.
Well, maybe it's time to learn something.
No, these maths are bad. It's just like, it's probably like implementing power. Like this one, pow xn is probably wants you to implement it. How's that a good?
No, do Excel sheet column number. That's useful.
Oh my god! All right, fine.
It's just math. You just count stuff.
You just count stuff, okay?
Yeah.
All right, fine. Given the
So
string.
they give you the column title, and then you convert it into a normal number.
Oh. Then how's that?
Yeah.
What is
Straightforward, right?
Is it though? Is it though? Okay, so literally. Wait a minute.
I think programmers in general don't know math very well. They're good at programming.
Why is this? How does it even make sense? Z is the 26th letter, right? Y is the 25th letter. What the hell does 701 mean?
Means in the. Oh, okay, so look at the transition from Z to AA.
Yeah.
right?
Mm-hmm.
So basically,
Oh, I
you can think of
see.
this.
There's just like a pattern somewhere. You just do the math and then you're done.
It's like base 26 kind of, right?
Yeah, kind of.
So you have to figure out how to convert stuff to other stuff.
Mm-hmm. Mm-hmm. So yeah, so it looks like okay. So typical stuff. All right, I think first you want a dictionary with A through Z mapped to the numbers. Or,
Sure.
wait, is it Yeah, dictionary is fine. Number value text.
You can do this in a list comprehension. You can do this in a dictionary comprehension, actually.
You know what?
Dictionary comprehension.
What the hell's that?
So it's like a list comprehension, but using dictionary. So you should do, I guess, okay, we're gonna do enumerate on A, B, C, D, F, G, blah, 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 right?
Yeah, but we don't have that. There's no string.
No, you just type it inside of here.
Type enumerate that and then ABCD.
Just type the whole string of capital letters. No, capital.
What do you say I'm doing?
I thought you wanted capital letters.
Oh yeah, sure. Oh, it's only.
But, I mean,
it's only.
You can do it that upper. You can do it that upper, and then you have to do it. Oh my god.
Whatever.
Okay. And then it's going to be tuples of index and value, right? Index and character.
Okay. But like I don't know what syntax you're going for. So I enumerate on this string and like what? Like what is the syntax?
Oh, so it's going to be like for x, y, and enumerate, right?
Oh, I see. Okay. So I still need the dictionary.
Right. So you no. You don't need that. You can wrap it around with the curly bracket.
Wait, so yeah, but then if you're defining it within the loop, it's gonna keep resetting.
No, you don't need a loop. That's what I'm saying. It's going to be in.
You just said for x and y and enumerate. That's
no,
a loop.
That's going to be inside of the curly bracket.
Oh, you mean like that?
Yeah, but you need now to define it in the left, right? So you need maybe like x colon y, right? But what do you want the key to be, and what do you want the value to be? No, you don't need to call it. No.
Okay.
Like the beginning.
Like
right?
that?
No. For x comma y is correct.
Okay, then what are you talking about?
Before the for, you can do x colon y.
Like that?
Right. So if this is what you want, then you can print it out. But if it's not what you want, then just print out value, and you'll see what I wrote. It's going. Basically, it will make the index to the mapping to the letter.
Oh, okay. So we just want +1 on it.
If that's what you want, yeah, sure. But I think you want the other way. You want the letter to map to the number. So you should do y colon. No. You can't +1 in the for.
Wait, no. Y is the letter. Why would we add 1 to y? We want to add 1 to x, right?
Yes, but that's in the definition of the mapping, not in the access.
What definition are you talking about?
So value dict equals curly bracket x plus 1 colon 1.
Yeah, so that's what I did before, and you said no.
No. You said for x plus 1 comma y.
No. I did it first here, and you said you want to do it elsewhere.
No. Well, that's correct, except you don't want this because you want y colon x plus 1 probably.
Y colon X plus 1. Wait, why do we want that?
Because the input is going to be.
Oh, we want this flipped around because we want to pull from the letter.
Right.
Is that, oh, that's what you're saying. Okay. That's what you meant. Okay. Yeah, that looks fine. Alright, so we have the dictionary. Now we just have to figure out how the math works. So if it's AA, it's just 27. So it looks like the logic there is it's Z plus 1.
Well,
so it's the previous letter. Wait, the previous. No. Wait, what?
how many different characters can there be in any digit, in any position?
26 in each position.
Right. So if you were to convert this into base 26, what would it look like?
Which one? AA?
Yeah.
How do you convert to base 26? Oh, is it just.
What is A? What is the value of A?
What's the value of AA? It's.
So what is the value of A?
Value of A is 1.
Okay. What is the value of A?
Well, that's. Well, they say it's 27.
Okay. And why is it 27?
It's because it comes after Z? I don't know why.
Sure. Okay. Then equivalently, what is the biggest digit in normal counting?
Biggest digit in normal counting is 10.
No.
No, it's 9. It's 9.
Yes. So how come the next digit is 1 and 0?
It's because it's the first digit plus pending the 0.
Right. So it's you're moving to the next space means that you're bigger than all the digits in the previous space.
Yes.
I mean, sure.
But this alphabet
So-
is a bit different from the regular number
It's
system.
different, but it's similar, right?
So okay, so the thing is, the logic flow is if it's A, but you have another letter behind it, then it's not 1 anymore. You have to map it to something. You have to map it to.
So it's 1, but you multiply by what? So one of the A's is 1, and one of the A's is what?
26.
Right. Which is 26 times 1, right?
Sure. Why is it times 1?
Because A is 1.
Okay, yeah, but like, so you're saying this one is 26 times 1 plus 2?
What?
The 28.
Yes. So
Okay, but when you get to B, is that 26 times 2 plus 2?
no. Why are you timesing 2? You're timesing the left guy, not the right guy.
No, I mean like when you get to BB or BA.
Oh yes.
Okay,
Right.
so that means the first letter is always 26.
No. So let's say you only have one character, then you're doing times 26 times.
Okay, so basically what you want is the last character is just the value itself, but any character
No.
preceding it is a
No, I
multiple.
think you want to start left to right. So you process a character, and then if you still have more characters after it, then you multiply by 26.
For the second character.
No, for what you have so far. Right, let's say you have AAA, right? Then it's 26, and sorry, it's
No,
1.
it's 1. Yeah, and then you have another character. So then so because you have another character, you just multiply the first letter by
You
26.
multiply what you have so far by 26, because when you're shifting a digit, it's always 26.
Oh, I see. Okay, so you're not technically multiplying the first character, because you have a total running at all times. You just multiply your current total by that base.
Correct. So then you can process all the digits.
I see. Okay, I think that makes sense.
As you go, right?
So yeah, if you have AAA, you check A. You have 1 as your total. You move over. Then it's another A. Then you multiply it by 26.
And then you add the A, which is 1, so it's 27.
Yeah, okay. And then
Then you
let's say you had a
again.
B next. Then you multiply
Okay.
by 26 again, and you add 2.
And then you do this until you out of.
Is it always?
Right.
Oh, so every letter that you move over, it's always 26. But okay, but how do you? When you jump to B, how does it know that it's actually 26 times 2 instead? Do you multiply by twice?
What do you mean? I mean, how does it know that you? What are you talking about?
Oh, wait. No. Oh, wait. No, never mind. I know. Never mind. No. I got it.
The only increment to B.
Yeah. I got it. I figured it out.
No, the program doesn't know anything. You know something.
Yeah. I figured it out. That was dumb. That was a dumb question. Okay. Frying column title. Current total. Just call it ret. Ret equals 0. Does 0 even exist? I don't think 0 exists. It's probably 1 at the minimum.
Okay.
Wait, does that change?
Oh, it should be 0.
It should be 0 because then it's because you're adding stuff. It's gonna mess it up. Okay, that's
If they give you nothing, you shouldn't return 1.
Okay. If no, it should be ret plus equals I. And then we just have a boolean. More letters equals column title when.
Do you need the boolean?
Kind of.
Or
How
can
else?
you just always 26?
Oh,
Can you just always multiply?
Can you though? If it's the first letter. If
0 times 26.
it's the first
0
letter.
times 26.
Oh, it's it starts 0. That's why. Okay, I see what you mean. Okay, fine. All right, so it's right. Is that valid syntax?
No.
Okay.
And then multiplies by 26 plus value, which is not even.
Is that valid? That should be valid, right? Times equals, does that exist in Python? Or no?
That's fine. That's
Okay.
fine.
Well, I don't like A somewhere. Oh, oops.
don't
I
like-
in. Letter.
No, then this is wrong because. Oh, no, this is right. This is right.
It should be right.
No, that's yeah, I'm sorry.
Oh, oops. They like the quotes. Okay, I think that's fine.
Why do you sound skeptical?
No, I'm always skeptical until the submission lets me go through. Right. I
No,
guess,
but you should believe in your method. Otherwise, like.
I mean, I do believe it. It's just sometimes it don't work.
I feel like you're the physical like third world country kid. So you're telling me this works?
Yeah. All right, one more, I guess. Maybe or no more.
Yeah, you want to do something else?
Let's do something
You
else.
wanted a trio graph, right? We can
Yeah,
do
let's
that.
do a tree. All right, but I already done this one, so let's do something else. Construct binary from pre-order. That's isn't that similar to what we did yesterday?
We'll do something else. Whatever. I don't care.
Oh man, number of islands. I don't know how to solve that one.
Let's do that.
No,
No.
that means it's
No,
gonna
no,
take a
no.
while.
So that's not gonna
It's
scale.
and it's a matrix question. I hate it.
No, it's beefs. You just do beefs.
It's just beefs. Okay, an island is surrounded by water and is formed by connecting adjacent lands horizontally and vertically. You may assume all four edges of the grid are all surrounded by water.
Okay.
Okay, so given an m by x, m by n 2D binary grid represents of ones and zeros. So 1 is land, 0 is waters. Return the number of islands surrounded by water and is formed by connecting adjacent lands horizontally or vertically. And we assume all four edges of the grid are all surrounded by water. Wait, when they're saying all four edges, they mean like,
Up, down, left, right.
are they saying like the out of bounds is the water?
Yes.
Okay.
So that means if the whole thing is one, then it still counts as one island, right? Because otherwise, you'd be like, what the hell?
So if you look at example 1, why is that one island? Is it because they're all connected into one thing?
Yeah. All the ones can be joined to each other.
I see. So as long as they're not, if there's no other one next to it, that means it's its own island?
Oh, no. So if all the ones are joined together, then they are one. They count as one island.
Yeah, but like if you look at example 2,
Okay.
there's the top left-hand corner. There's 4 ones, and that's not connected to the other one next diagonally.
That's right. So that basically runs out, and then.
So basically, you're just checking. Your BFS is checking to see if, as long as you can keep building left and right, that's one island.
Correct.
But if you can't, then you're done.
Or up or down, not just.
Yeah, left, right, up or down. Yeah, but the problem here is, okay. So if you're doing, I guess in your BFS, you check the first index. If it's 1, you push it to the.
You make a queue.
Yeah, you push it to the queue, and then you check every up, down, left, right, and then if those are ones, you put it into the queue as well, and then you just keep doing that until the queue is empty. But then, how does it get to the other ones?
Okay. So I mean, there's multiple ways to do this, right? One is just keep track of at the beginning where all the ones are, right? So you can go through and say, oh, this is 1. I'm gonna leave it in the queue, right? And then have some kind of like visited thing that says if you processed it already, don't bother. If you haven't processed it already, then this counts as a new island, right?
So what you're saying is, firstly, build an index of where all the ones are at.
That's one way to do it. The other way is you can modify the grid, where if you're like, oh, I found a 1, then basically you beep out, you basically relabel it with zeros or something, right? And then it's like, okay, I count this island, but every neighbor to this will now be relabeled as 0. So then you'll never run into another one that you dealt with.
Wait, but you can't do that, right? You're saying if you look at index 00, that's a 1.
Yeah.
And then you're gonna set everything next to it to zeros? Oh, you're setting itself to 0.
You set itself to 0, and then you find all neighbors. If they're 1s, set them to 0 as well.
Okay, but that's bad, right? Then how do you know where the island is?
But it doesn't matter. You just care about.
Oh, you're just counting. So
Yeah.
so because you found a 1, you instantly have
You're
one island,
guaranteed to have at least one island,
and then you just BFS to set all the adjacents to 0.
including itself.
Yeah.
Right. So
And then once that's done, then you keep going.
Right. So then when you explore the next one, you know it's a new island.
Yes, but the problem with that is when you do neighbors, that's a lot of extra runtime, isn't it?
No, not really. You also have to keep track of, like, did I process it? Actually, no, you don't have to keep track of it. If it's 0, then you don't care.
Yeah, if it's 0, you don't care. I know, but like, oh yeah.
So
all the extra runtime is only when you're tracking neighbors. If you're not tracking neighbors, it's just O of n running through the grid anyway.
No, but you have to track neighbors.
I know. You only have to track neighbors if it's 1. Otherwise, you don't care. So that's why if you flip to 0, it should be fine.
There's a slight caveat where, I guess, you usually want to be careful you don't run into infinity. But that's fine. I think that's a valid approach. So
Okay,
it's up to you.
so let's so I start at so I'm just looping through the m by n array from at the start. If I found a 1, I go through all the neighbors and set them all to zeros. And then I
You
check the
set
next
it up.
element. If the next element is a 1, I do the same thing. If it's not, it's 0, I just keep going. So basically I only process 1s and I set all the neighbors to 0.
Right.
Okay, and then while I'm doing wait, is it possible that there's a problem with that? Because then like if you do that, right? Wait, no, that's because yeah. Let's say you had 1 right here, right? In example 2, it 1 in position 0 0, right? 1 in position 0 1, but then also another 1 in position 0 2, right? Oh wait, no, that because then
Oh, by
oh
doing
that
BFS,
when you
really can't.
no no it won't though because then like if you do the 0 0 first, right, and then you change itself to 0, you change all the neighbors to 0.
No. You add them to the queue and then you change them when you call them.
Oh, okay. So you're not literally changing them instantly. You still have to do the
No, no.
BFS. Yeah. Okay. So you still have to do BFS.
Right. You always have to do BFS if you're choosing to do BFS. That's the whole point.
Okay, because you made it sound like I didn't have to BFS anymore. You just set them to zeros.
You can do DFS, but it's the same thing.
Okay. Okay. I see. Okay. That's fine then. Okay. So if I do that, so I'm just doing BFS every time I find a 1.
Yeah, exactly.
Okay. All right. So for row and grid.
Well, I typically for grid problems I do rows equals length of grid.
Yeah, you just said it earlier, right?
And then it's much clearer what you're trying to do. You can do R in range rows or row in rows or row in range rows probably, right? One range.
Okay, so if grid row col was 1,
Right, then you make
stack.
DFS queue.
Oh, that's not frontier equals grid row column. And then I do while frontier dot pop. Wait, this points to the grid var. So if I literally set that to 0, it should affect the grid, right? Because it's
Yeah.
okay.
It will.
Okay, so it'll be like L equals this, L equals 0, and then neighbors.
Hang on.
What's
Your
up?
frontier will grid row column is going to be 1. So here your frontier is going to be 1.
Oh, whoops! Yeah, you gotta set the. What do I want? The row column, I think, as a tuple.
Yeah, fine.
Wait, do I want that?
Why not?
Yeah, that's fine. Okay, so it'll be row RC.
Also, you should be copying the first guy.
Hmm?
You should be copying the left guy.
Oh yeah, right. Pop is stack mechanics. Sorry, I need to DQ this. And then neighbors is the
You need to wrap the DQ around.
Oh, right. You mean like that? A lot of parentheses. Okay, neighbors is row, and then column plus 1. Row plus 1 column. Row column minus 1. Row plus 1 column minus 1. Is that? I think that's fine. Wait.
Okay.
That doesn't look correct. That does not look correct. Okay, wait. Row plus 1 is the right element, and then you want to keep column. Okay, so this is the right element, so that's fine. This is right. What is this? What is row and column plus 1? Column plus 1, that's up. No. Yeah, that's fine. We want that one. What is row and column minus 1? Row and column minus 1 is... No, plus 1 is not up. Plus 1 is down. Minus 1 is up. And then row plus 1... Oh, it should be row minus 1. Row C minus 1. I think.
No, not C minus 1. It's row minus 1 C.
Wait, is it? Okay, wait. Row minus... Oh, yeah, that's left. Yeah, okay. That's fine. Okay, and then for neighbors, for x, y, if x greater than 0 and y greater than 0.
Equal also.
Alright, yeah, equal. And x less than when grid and y less than grid.
Well, we already have that in grid. It's rows.
Yes. Okay, if those conditions are true, then you check. Wait, is there another one? It can't be greater. It can't be. The out of bounds is only. Wait. Yeah, column.
No. So the bounds is right, but what? When do you add to frontier?
Oh yeah, I didn't do that check yet. If it's 1. Yeah, okay, fine.
Right.
Yeah. And grid x y is 1. Frontier dot append x y. Okay. Yeah, that does all of it, and then while the frontier it finishes this, and then that should set everything to zeros. But I need to count the islands.
Exactly.
So I need ret equals 0. If this happens, that means you increment it. And then it does all the frontier stuff, and then you're done. And then it should exit, and then the next time you find another one, it should increase by 1 again, and it does the whole shit again. So that should be fine.
Okay.
Okay.
Alright, are you skeptical?
I'm not skeptical, but just check. But then I know if you copy and paste these, it doesn't like it. It's so annoying. And I don't want to deal with it, so I'm just gonna hit submit. Oh, there you go. There I go, how fast.
This is there you.
It's frogs. Okay, what's wrong with this one? For expected answer 3. So what am I doing here that's wrong? Let's see this island crap. Okay, so there. Oh, this is just the first example. How is this wrong? What did I do that's wrong here? So the algo would check this grid equals 1. Increment red by 1. So red is 1. And then
Oh no, I know what.
Already?
Why do you in line 28? How come you check rows twice?
Because X and Y both have the less than rows, right?
What are you talking about?
Oh wait, no, X is rows. Y is not rows.
What the hell is this?
Oh wait. If that's the case, oh no, 0 checks has to be on both for sure. It should be and Y is less than column.
Yes.
Yeah, that's
right.
Okay, let's see. Oh, there we go. Nice.
Wow.
GG's.
No.
That would have worked if it was a n by n grid, not a mxn. But then they
No, that works because that means if you're in the bottom row, then you just don't count it, or you count it extra or something. Right?
Well, I get a time limit, Alphaz.
Huh?
I got a time limit to exceed it.
Oh shit. Oh, then make a visited thing. That's easy.
So wait. So if you visit it, don't put it into the frontier, right? Is that what you're saying? Okay. So so I have to make a new tuple. I mean, I have to add a new thing here. True.
Yeah, they always try to get you with this shit. Really annoying. Okay, what's true? No.
It's
No.
No, the first element, the first one you always put. Oh wait, no, it's false because. Wait, yeah, because then you need to pop it first. Wait, no. If you popped it, you're fine, right?
No. First of all, you should never even. No, just make a set outside, and then you append when you visit.
What do you mean a set outside? What are you talking about?
So, no, just have a visited set that is outside of everything.
Oh, you mean literally just a set of the stuff you visited already.
That's right.
So it'll be like.
Right. So then, when
you
you
visited that add RC, and then if
so the neighbor has to not be invisible.
The neighbors can't have invisited, but then. Okay, yeah, because then if you're adding or minusing numbers, it's possible that it's already visited.
Yeah.
Okay, so I can't hard code these. I have to check.
Oh, you can.
What do you mean?
In line 30, you should just say and x, y not invisible.
Oh, so you're still gonna loop through the neighbors anyway? I thought you need to like not put it into the neighbors. I guess it's always hard coded to 4, so it's not a big a deal, right?
Neighbors is always right. It's fine, but you need to make sure you haven't added that before.
Yeah, that's what I'm saying. I'm just saying like my logic was, if that was already visited, you don't even put it into the neighbors array. But then I guess that it's just easier to just put it here.
Right, and they just don't append it, which is fine.
How do you space this out, or is it has to look like this?
No, not neighbors. It's visited.
Oh yeah, but how do you space this out in Python? Okay. Oh, this is not gonna run.
Copy that. Yeah. No, you misspelled the call
What?
it listed.
Oh. Oh, wait a minute. Wait a minute. No, no, never mind. I did add it. That's fine. What? How do I still have a visit? Visit. What? What is this? What is this showing me? Oh, he's here. How come I can't spell visited?
I don't know. Maybe like listed. That's fine.
Oh, it's still running a long ass time. It might get TLE.
Hmm. That's annoying.
I think it's because you're doing. It looks you're still doing DFS on every one. Wait on. No, it's because you finish DFS, and then you move to the next element, and you do DFS again if it's one, and move to the next element, and then I guess it's just too much elements still.
No. Something is. What did I? Okay. Okay. Let's see. What did I do? The idea is alright. It's just
Mm-hmm. Some mistake somewhere,
Yes.
or
I don't remember. I don't think I did anything different.
really, and it worked.
Maybe I didn't initialize frontier every time. I set frontier at the beginning.
Huh?
I set frontier at the beginning, like where. And I didn't even have it visited actually.
And it worked.
I think you're initializing the DQ thing every time might be the slow part.
Oh, so instead of doing it outside, just do it.
Yeah, in fact, I didn't even have a DQ. I had like a normal stack.
So just do it out here. But then I don't have row column.
No. Then
Oh, you mean? Oh, I see. So it's just empty DQ, and then I append to it.
sounds crazy to me that that's the actual thing. Yeah, just empty DQ, and then right. So if it's equal to one, then you add two.
Okay.
Right. Try that. Let's see how that would be any different.
It's still taking a long ass time.
And it's possible that they've updated the test cases since I
Oh,
did this.
yeah, maybe.
Maybe very recently what I had.
Unless I have a mistake somewhere that's just calling a bunch of extra stuff for no reason.
Huh. I'm still getting accepted. So what the hell?
Yeah, so I might have a mistake somewhere.
Oh, I have a thing where if the XY is less than 0 or greater than rows or greater than calls, then I continue. Maybe that handles a lot of those cases.
Where do you continue? In the neighbors portion of the loop?
Oh, I see what happens. Oh, okay. If next, okay, so I actually set it to 0 first before I add it to the frontier. That probably optimizes some stuff.
Wait, how does that optimize anything? That doesn't make sense. You're just flipping the var before I flip it later, but it doesn't do anything. It's not like I call.
No, it does do something because then you don't. you don't deal with the one again, right? But it's still in the queue, so that means you're able to process its neighbors, which is good. But you don't process it ever again.
Yeah, but okay. So if I do it afterwards, you're saying I don't do it again, do I?
Um, no, you might, because now you still you check neighbors before you add them.
Yeah, but you're supposed to do the neighbors regardless, right?
Neighbors is fine, but you want to apparently if you set it to zero first, then you save a lot of time.
That makes no sense, but I'll try it out.
So if grid of x comma y equals 1, then you set grid uh, x y equals 0, and then you still append it to
Yeah, I'm still appending it. I'm just saying I'm setting it to 0 now, but I don't think that changes the speed of anything. That makes no sense. Because if I do it here or there, I don't. Does that change anything? That's weird.
line 22 is fine. Line 34 is what you want. You want a new one.
I want a what?
You want to add the equivalent of line 22 to line 34.
Oh, I need to set the neighbors to 0. Oh, I forgot to do that. So it was not this. It was just I never set these dudes to 0.
Right.
Oh, that's why. Oh, yeah, that does save a lot of time.
Then it only sets it when it pops it, which is that's slow. Right?
Yeah. Okay, I see. Wait, does that save time?
And then you don't need to visit it at all.
Yeah. I still don't see exactly how that saves time, but I guess it's fine. Oh, oops. Visiteds are gone now. Okay, it looks fine now.
Well, it's a lot faster.
Yeah, like instant speed. Why? Why does doing this do anything? Because then in my previous logic, when I append it to the frontier, it's gonna set it to 0 the second it goes. It pops it anyway. I don't see how that affects anything. That makes no sense to me.
I think it's because it guarantees you don't ever check that thing again.
Yeah, but I'm not supposed to check that thing ever again anyway.
Also, let's say you have the upper left corner, right? You add 0, 0.
Yeah.
Then because it's not set to 0 yet, you're gonna add 1, 0, and then 0, 1, and then I guess.
Oh, this neighbor still thinks this is 1, so it's gonna do it that one also.
But it doesn't know.
Yeah, it doesn't know. No, it's because when you did the neighbors with this one, and then you put into the array, then this guy is in the frontier and he gets popped. And he says, "Hey, what's up? That neighbor's still 1," and he does it all over again. I think.
Right. But if it was set to 0 before
you append it, then this guy doesn't have this neighbor as anymore. He's that guy's 0, so we don't have to do him again. So I think it's just doing it multiple times or something like that. Okay, right. I see. Okay, so basically you just want to preset to 0, so you don't have that opportunity to multiple call on the same element.
Right.
Okay, that's fine.
Yeah, very good.
All right, thank you.
Yeah, I guess I'll call on.
Okay, bye.